Tommy likes to run up and down an up escalator. Going up, he can cover 30 steps in 6 seconds. Going down, it takes him 15 seconds to cover 30 steps. Find Tommy's rate in steps per second if the escalator stopped moving. So this is a distance, rate, and time problem, which is why you can see that I've created a rate times time equals distance chart. Something really important to realize in this problem is that Tommy is going up and down an up escalator. So what this means is when he goes up the escalator and the escalator is going up as well, they work together. So that means they're going to go faster. Tommy's going to go a lot faster going up the up escalator than he is going down the up escalator. So notice underneath up I wrote he's going with the escalator. When he goes down the up escalator, he's moving against it. So it's going to slow him down, which means we're going to have to subtract the rates. So the next thing I'm going to do is go through and find the important information. When he goes up, he can cover 30 steps in 6 seconds. So over here, 30 steps is our distance, 6 seconds is our time. Going down, it takes him 15 seconds to cover 30 steps. So 15 seconds is our time, 30 steps is our distance. Now the next thing we have to do is we need to actually identify some of our variables. So because we want to know Tommy's rate, that's our first variable. So T is going to be Tommy's rate. But the other rate we have to consider is the escalator's rate. So I'm going to let E be the escalator's rate. So over here, when he goes up the up escalator, Tommy's rate and the elevator's rate work together to go faster, so they get added together. When Tommy goes down the up escalator, they work against each other, so the escalator's rate goes against Tommy's. And Tommy has to be going faster, otherwise he won't be able to actually go down the up escalator. He would just stay where he's at. So Tommy's rate has to be more than the escalator's rate. So now we have this system. And because I like to put the number in front, so instead of distributing backwards, I like to distribute forwards, we're going to have 6 times T plus E equals 30. And then would have 15 times T minus E equals 30. So here's our system. Now we have a choice. We could distribute 6 times T, 6 times E, 15 times T, 15 times E. Or we could be smart and we could divide both sides here by 6 so that we would end up with T plus E equals 5. And then here divide by 15. So we'd have T minus E equals 2. Now, it's your choice. You don't have to do it that way. That's just one way to do it. But notice that when I do it that way, I end up with being able to cancel out these E's. It's already set up for elimination. So I end up with 2T equals 7, which means that T, when I divide by 2, equals 3.5. And that's particularly easy to get that way by dividing instead of distributing. Now, if I distribute, it'll still work. You're just going to have to come up with common, if you want to use elimination, opposite coefficients. So now I could find the escalator's rate. 3.5 plus something equals 5. Well, that's something, that E, is going to be 1.5. That's what equals 5. But I don't need to find it because all they asked me to find is Tommy's rate. So over here, Tommy's rate is 3.5, and that's going to be steps per second. So if you've already found your answer, you don't necessarily have to find the escalator unless you just want to, and you're done.